Give the IUPAC name of the following. Well, IUPAC is International Union of Pure and Applied Chemistry, the kind of nomenclature that has been said that anyone around the world can use to name organic compounds and just other compounds. Now, for this one to be able to name, we first need to identify the functional groups which are present. So we have got an hydroxyl functional group showing an alcohol, and then you have got a carbon double bonded to oxygen and then H. So this functional group is an aldehyde. As long as it is at the end of the chain, that's an aldehyde. Now, which one has got higher priority? Well, the aldehyde has got higher priority than the alcohol. And so the parent name here is going to take up the aldehyde. And the first thing that we're going to do is we're going to count this chain starting from where the aldehyde is connected. Well, there's a carbon here even if we can't see it. So this will be position number 1. We always count from where the function group of highest priority is, and then so be carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. And so to be able to name this, first the alcohol is going to act as a group. Now if we can look the way the bonds are, this is showing stereoisomerism. This means that this group is entering in the page, and then this one is coming towards us. And so this, because the groups are on two opposite sides, that leads to a trans isomer. If they are on the same side, that would have been a cis isomer. So this is trans. At position number 2, we have got an alcohol group and we call it hydroxy. Now, the whole of this chain has got 6 carbons and it has got only single bond, that is a cyclohexane. Okay. Now, this group is an aldehyde. But whenever we have got a function group as an aldehyde and it's not part of the longest chain, it will not be called aldehyde but carbaldehyde. So that is going to be the name, trans-2-hydroxycyclohexane carbaldehyde. So that is the name for the first one. And for the second one, to name it, we are going to first identify the function groups present. We have got an alkyl and then an alkene. An alkene has got higher priority than alkyne. But when we are counting, we need to count in the direction that will give us a lower number. We don't care what receives the lower number. So if counting from this direction gave a lower number to the triple bond, then we are going to consider counting in that direction. But when we start from here 1, 2, we are getting the triple bond at position number 2, and then we start here 1, 2, we are getting the double bond at position number 2. So we need to go in the direction that will give a lower number to the double bond. So this will be position number 1, number 2, number 3, number 4, number 5, number 6, and number 7. So a chain of 7 carbons is called hept. When we are naming where we have got an alkyne and alkene, an alkene will always be named first. So this is hept. We state the position of the double bond, that is to always get the lower number, not the 3. So that will be hept 2 in. But this is not an alkene just like that. That's not a parent name. So I'm going to remove the E at the end. So that will be hept 2 in. And then put the position of the triple bond, that is position number 5, and then finish ion. So that is hept 2 in 5 ion. I could have also said at position number 2 I've got a double bond 2 heptene. But it's not the parent name, so I'll remove the E at the end, put a dash, and then put the position of the triple bond, position number 5, and then put ion. So that is it. That is how we get to name these two.